Okay, shall we start? You're supposed to stand up and say good evening, no? Like today's like third day. Okay, good evening. Okay. Okay, so today we are in the third day of the 2028, can see? Okay, 2028 English medium combined maths class, and like every time, like every week in the first 2 3 months, since newcomers are joining the class, I normally say, like I talk what we have done for the past 2 weeks. So as the old students know, what we have done for the past few weeks, past 2 weeks is in the very first day, we talked about, even this is applicable for the students who have joined online. So we started the class 2 weeks back, and in the very first day for 2.5 hours, I was talking about all the paths and all the careers that you can follow if you do A-level maths or the physical science stream. Starting from sounding okay. Starting from engineering, physical, then architecture, even fashion designing, and then data science, AI, the IT sector, all the fields were discussed during the first 2.5 hours in the very first day. And then we started this part called basic maths concept or basic mathematical concepts. I'll just write basic maths concepts. So why did we do this? Why are we doing this part? Is because I told you about this graph. So when we refer to your maths knowledge starting from zero, it comes to a certain stage when you complete your O-levels. And after O-levels, if you are doing, so this is your the maths knowledge. If you are doing any other stream, you're doing bio, you're doing commerce, tech, or arts, this maths knowledge is more than enough. Huh? It's more than enough. But if you're doing A-level maths is starting somewhere from here, which means there is a small gap, not a huge gap. There is a small gap between where you stop during your O-levels and where you start your A-levels maths. So through this basic maths concept part, I'll be covering this gap. And I won't say that in these 4 days that we are doing basic maths concept, this gap will be entirely covered. But when we are moving on with the other lessons in the A-level syllabus, these parts will be covered. Okay, and I'll make sure during the first 4 weeks or 5 weeks of the class, even if a newcomer come to the class, let's say someone is coming to the class next week, still he or she can easily understand what we are starting on that day, what we are teaching on that day, because every day we are starting with a new part. Even today, like when I ask you to write the note, what you have to do, even newcomers, just write the main topic, basic mathematical concepts, and then you can start with a new topic. We will be starting with a new topic, expansion of the addition of two cubes and the difference of two cubes. So you can easily understand the lesson, what we have done, what we will be doing today. And you don't have to keep any space, like keep any pages, blank pages to cover the previous 2 weeks, because you can do that in this way. At the end of the class, I'll tell you about the Telegram group that you need to join and how you can watch the previous 2 recordings that I'll tell you at the end of the class. So then leisurely you can go through those recordings which has been uploaded to the group, and you can cover the first 2 weeks work. Now you can just start from the very first page. You don't have to leave any page. And especially like I advise to watch the first day recording for sure, because then you have a comprehensive idea about understanding about this A-level math stream. What are the paths that you can follow? What are the careers that you can follow if you do this physical science stream? Okay, so everyone, like all the previous students, you have to just put the topic that we are going to start today. Other students, the new students, put the main topic, basic mathematical concepts. Put the main topic, the new students, basic mathematical concepts. Basic mathematical concepts. Even this is applicable for the online students. If this is your very first day in our class, put the main topic, basic mathematical concepts. And everyone write the topic. Write the topic. Algebraic expansion. Write the main topic, algebraic expansion. Algebraic expansion for the addition of two cubes. algebraic expansion for the addition of two cubes. For the addition of two cubes. Okay. Okay, now you know how to write a topic properly. Last week I mentioned how to write a topic properly. Which letter should be capital and which letter should be simple. I mentioned that last week. No, when you're writing a topic, make sure that the main words, like excluding these prepositions of at the, other words should be started with a capital letter. That's how you write a topic properly. Okay, so here the algebraic expansion for the addition of two cubes. Okay, now this is what we're going to do. I need to write an expansion. No, I need to factorize. Factorize a cube plus b cube. So this is the addition between two cubes. Okay, I need to factorize this. A cube plus b cube. So this is the addition between two cubes. Cube means the third power. So what we do here is, first I'm considering the algebraic expansion of a plus b cube, which we have done last week. And even you have done this for levels. So what is the expansion of a plus b cube? We have the two cubes. I told you that we are not going to memorize the exact expansion. We are just going to keep in mind the shape of the expansion. So those are two things, not memorizing. I don't memorize this. A plus b cube is equal to a cube plus 3a square. No, I'm not going to memorize. What I am going to do is I'm going to just keep in mind the shape of the expansion. So what is the shape? The shape means we have the two cubes, a cube and b cube. And then we have 3 times this term squared into this term, and you need to do it in the opposite way. This term squared into this term, and you have to do this in the opposite way. This squared into this, which means 3a squared b plus 3ab squared. 3 times a squared b and 3 times this squared this, and we have the cube. So this is the expansion of a plus b cube. And now what I'm going to do is I need to factorize. I need to write the factors of a cube plus b cube. My intention is to factorize the addition of two cubes. We call it as the algebraic expansion, or you can even consider it as the factorization of the addition of two cubes. So these are the two terms that I need to have. Now I'm going to isolate these two terms. So I'm going to send this to this side. I'm going to send these two terms to this side. And then I have a plus b cube minus 3a squared b. When you take this to this side, you get minus 3ab squared is equal to a cube plus b cube. Okay? Okay, so now I'm not going to send any of these terms to both sides. What I'm just going to do, I'm going to flip this equation, which means like if we have a equals b, I can just change these two and write b equals a. No, I'm just changing the sides. It's not that I'm taking this to this side and this to this side. When a is equal to b, b is equal to a. No, a equals b, b equals a. This is something new to you, no? Like you have to give some like feedback. It's not like if it's hard, like I have talk about feedback. No, when we teach, when we lecture, we need feedback. Because that's why it's hard to do a peer online class. When I'm doing a peer online class, I can't properly see whether the students understood this or not. So I need your emotions. You're humans, no? And even like I want some feedback and emotions when I say something, like because when I look at your faces, zero emotions, nothing. Like when I say a equals b, we can write b equals a, at least. Yeah. If it is yes, yeah, I know. So we can write it. Yeah. No, I don't know. So if I ask something like whether it is clear, because I can't ask you, hands up who understood this. Hands up who understood this. Probably you know this, no. So I won't be asking whether you understood this. Okay. Sometimes like you are even giving me goosebumps, whether like I'm not sure whether you don't know this one, because you came here to do A-level maths. And I'm having a doubt whether you know this one. A equals b, so b equals a. I need emotions. If it is yes, yes. No, no. Because if not, I'm just teaching here, and when I look at this audience, look at the students, zero emotion. It's hard to do that. How to continue? Okay. So here what happens, I'm not going to change any of these terms. I'm just flipping the two sides. So here, this I'll just write from here. We have a cube plus b cube is equal to a plus b cube minus 3a squared b minus 3ab squared. So here I have this a cube plus b cube is equal to a plus b cube. Here I can see common minus 3ab is common. 3ab is common, and here we have a plus b. So this expansion is even used as the addition of two cubes. This is not the final answer. I'll tell you why this is not the final answer. So here, this expansion for the addition of two cubes is even used. When we have this a cube plus b cube, even you can write this. This is equal to a plus b cube minus 3ab plus, into a plus b. But this is not a final answer. You need to memorize, or you need to keep in mind, this is not a final answer. I have just boxed it to give you an idea that even this is used. For example, in these days, we are doing quadratic equations for the 2027 class. And even in this quadratic equations lesson, this expansion was used. When we had this a cube plus b cube, we wrote this expansion. So this is not the final answer, but this is even an expansion that we normally use for the addition of two cubes. Clear? Okay. Now my question is, I told you my intention is to factorize or write the factors for the addition of two cubes. That is my idea. My target is to write factors or factorize the addition of two cubes. Now you tell me, if my intention is to factorize the addition of two cubes, why can't I accept this as a final answer? Why can't I accept this one as a final answer? Why? No one. Why can't I accept this as a final answer? What is the meaning of factors? What do we do when we factorize? A factors means we have to write it as a product of the terms. So factorizing means we have to write someone as a product of terms. Is this a product of terms? No, this is not a product of terms. This is not a product of terms. So these are not factors. This is just an expansion. Okay. So then I need to simplify this further in order to factorize this. So when you factorize this, when you pull out a plus b, which is common, a plus b is pulled out. We have 3a plus b, so 1 has been pulled out. So 2 is remaining, a plus b squared. A plus b is taken out, we have minus 3ab. And now we can factorize this, simplify this, sorry, not factorize. We have a plus b, simplify this, a squared plus 2ab plus b squared minus 3ab. So that gives me two factors for the addition of two cubes. It goes in this way. We have a plus b. If it is a cube plus b cube, we have a plus b, a squared plus 2ab minus 3ab is minus ab plus b squared. Now look at the shape of this. What is the shape of this? When you have a cube plus b cube, the addition of two cubes, we have to factorize it. So these are factors. Clearly the product of two terms. Clearly the product of two terms. If it is the product of two terms, we call it as factors. Then a cube plus b cube is equal to a plus b, a plus b. We have the square root of the two terms with a minus ab, or minus product of the terms. So that's all. You have to keep in mind the shape. When it is a cube plus b cube, we have a plus b coming in this way. And we have the two squares together with minus the product of the terms, minus AB. Okay. So now this is the thing, when I did this in the single medium online class on Friday, because like students at the initial stages of the class, normally students tend to ask these type of questions, and a student was asking me, so why is this minus AB? His question was, we have a cube plus b cube, but in the expansion, it is a squared minus ab. So even I don't have answer for that. His question was, so why is this minus AB? We get minus AB because when you simplify, we end up with a minus AB. So that is what we get when you simplify. We don't have a logical explanation for why this become minus. Why did this become minus? Those are not logical explanations. Why did I get minus? Because when you simplify this properly, plus 2AB minus 3AB, you end up with minus AB. Clear? Okay, just keep in mind the shape, and I don't want anyone of here to remind, like memorize these overnight. So next week when you come to the class, you know a cube plus b cube is equal to this. No, that is not how we do this. Okay, you don't have to memorize this, but when we use these in the 2 years, when we use these expansions again and again, these expansions register in your mind. You don't have to memorize this by giving an effort. Okay, just we will be using this again and again. So when we use this again and again, these equations and all the expansions will be registered in your mind. For that purpose, we will be using this, and even we'll be doing homework and other stuff to make them register in your mind. Clear? So this is what we do. I needed to factorize the addition of two cubes. I started with a plus b cube. I started with this a plus b cube. And then I isolated this, and then I simplified. What is this? Why I have boxed this using dotted lines? This is not a factorization, but still I told you, even there are instances when we have the addition of two cubes, this expansion is used. This expansion is used. Clear? Okay, then write in this way. Let's factorize. Let's factorize the addition of two cubes. Let's factorize the addition of two cubes. Within brackets, write this: a cube plus b cube. A cube plus b cube. A cube plus b cube. Okay, then using the expansion of using the expansion of a plus b cube. This using the expansion of a plus b cube. A plus b cube. Okay, start from the expansion of a plus b cube, isolate a cube plus b cube, and get the final answer. Even box this using a dotted line. I'll give a small explanation for that. And students who have joined online, make sure that you get the tute before we start doing questions from the tute. Okay, students who have joined online, make sure that you contact the numbers and get the tute if you don't have it with you so far. Okay, so then I told you how to keep the shape of this one, just simplify and get the answer, and then I'll write it properly. So this is what we have, the addition of two cubes. The factorization is we have a plus b, and then I told you we have the two squares together with this minus ab, minus ab plus b squared. A squared minus ab plus b squared, and this is how we factorize the addition of two cubes. This is how we factorize the addition of two cubes. Okay. Now let's see how this is applied. Last week we did question number 5, but no, I think not 5. There was a number here. According to the numbers what we have done question number 4. So I'm referring to question number 3. 3 means page number 2, the second page, top question. So there are two. Question number 3 is its error here. So I'm referring to the second 3. Yeah? Using the factors of difference of two cubes and addition or sum of two cubes, factorize this. Question number 3, second page, top question. So first one, question number 2, we have x cube plus 1. We have x cube plus 1. So what is this? This is equal, look at the board. X cube plus 1 can be written as the cube of 1. And then we have, so x, we have x plus 1. We should have the square of the two terms together with the product, but minus. So how do we, you don't have to write in this way. You don't have to think in this way. Here a equals x, b equals 1. No, you don't have to think in that way. So that is a complete, in maths, we don't memorize. Always keep in mind, maths is a logical subject where we have to limit the amount that we need to memorize. And we are going to apply these logics and all these equations using the limited amount that I have memorized. So it's not like we can't do maths in the way that chemistry is done. Chemistry is a subject where you have a huge amount to study, to memorize. Not 100% of chemistry is to study or memorize, because even chemistry, there is a mathematical part where you have to solve problems and all these. But at least we can say that 70% of chemistry is that you need to keep them in mind. You need to study. Maths is a subject that you have to study or memorize only a limited amount of stuff, and then you have to apply those things. So that is how maths is done. So that's why a student who doesn't like to study that much, so that's why a student in that way likes to personally prefer maths. And maths will be the subject if you are a student who has a good logical thinking and who doesn't like to study that much. You will personally prefer maths because you don't have to memorize these maths equations and all. In maths, you don't have to have the short notes in these stuff. No. But chemistry is a subject where you need to memorize. For example, history. History, you can't go to the paper and think and write something. Can you think history? You get a question, who was the US president when the Second World War started? Not Donald Trump. So can you logically think? Can you just solve an equation to get the answer? It was like Franklin Roosevelt. No, you can't do that. So you need to know that. So similar in chemistry, let's say there's a chemical compound and you are supposed to, the question is, what is the color of the chemical compound? Can you go to the exam and get it using a formula and derive what is the color? No, you can't do that. Yeah, so math should be done in a way that it should be done. You are not supposed to you're not supposed to memorize this. And you are not supposed to think in this way. Here A is X and B is 1. And you apply in X and 1 instead of A and B. No, just keep in this. We have the two terms, X plus 1. We have the square of the two terms together with the minus product. That's all, minus product. And then you can simplify x plus 1, x squared minus x plus 1. That's all. So I'll do another one. Question number 5. We have 8a cube plus 1. Question number 5, 8a cube plus 1. Okay, 8 can be written as 2 cube. A cube plus 1 can be written as 1 cube. So we have 2a cube plus 1. That's all. Now you don't have to think, here A is 2A, B is 1. No, not in that way. Now tell me how you're going to write the factors. Easy. Tell me. Tell me. I need answers. I need to hear. So we need to have the class in a engaging, energetic way. Yeah, I do the classes even though I'm tired or not. I do the classes in an energetic way. So if I give a good effort here and I look at you, I need answers. Hey, sleep in, doi. Okay, sit properly. I need my students to stay in the class in energetic mode. Like you are my motivation. When I look at the board and write something, and when I look at you, I should see these like fresh faces, these focused faces, attention, like you are giving a good attention. Not that when I'm looking at this board and I'm looking at you. No, those are sleepy faces. You are my motivation. Keep in mind. Okay, you are my motivation when when I talk on the stage. Okay, sit properly. Sit properly. There's a cushion that you were supposed to keep your back on that cushion. Haven't felt it yet. Now you should feel it. Okay, sit properly. Yeah, and don't stay in these postures. In these postures, those are sleeping postures. Easily you can sleep. You're looking at the board. You like in the you zone out, and then you are going to a parallel world where you are rich man driving your vehicle and having your these luxurious pet dogs and all. Okay? So we are in the realistic world, not in that world. Huh? Okay, I need everyone to pay attention. No any sleepy faces because I'll be giving like a personal eye contact if I notice that you are sleeping. You are in a sleepy mode. Done. Okay, good. So here, now tell me, how can we write the expansion? Do we have to think this is A, this is B? No. No. How can we write the expansion? It's simple. Tell me. We have the addition of the two terms, 2A plus 1. Then you have to consider the square together with the minus product. Also, we have to consider the square, sorry, it's A together with minus product. Minus 2A into 1 plus 1 square. That's all. And then you can write this. This is equal to 2A plus 1. And then it is a normal simplification. 4A squared minus 2A plus 1. That's all. So that is how you do. Okay, so write this, box it, do question number 2 and 5. You can put a tick near question number 3. And I need everyone to do this expansion properly. The next one, it's 8m cube plus 27. First write this, box it, do question number 2 and 5 as per on the board. You can mark that you have done question number 3, and then do the next expansion. And when I ask a question from the online class, the physical class, I need even students in the online class to answer. If I ask a question, if I ask from the class that hands up whether we understood it or not, I need even answers from the online class. Okay, so this one, first you need to write it as the addition of two cubes. So we have 2 cube, m cube plus 27 is 3 cube, is the cube of 3. Okay, so here you have 2m cube plus 3 cube. And when you have the addition of two cubes, we just learn it's equal to 2m plus 3. It's equal to 2m plus 3. And then you have to consider the square of two terms along with minus the product. So minus 2m into 3. You have to consider the square of the two terms together with minus the product plus 3 squared. Which means we have 2m plus 3 and 4m squared minus 6m plus 9. Now we have 4m squared minus 6m plus 9. So this is the expansion. Okay, so here, like normally when we do these expansions at the initial days, some of the students ask in this way, so can't we directly write this one from here? Do we have to separately show that 8 is equal to 2 cube? No, you can write this. And even if you are really good in simplification, you can directly write this from here. You can write it. If you are really good in simplification, you can do that. But I know you are just restricting to do that. The reason is in O levels, your simplification has been killed. The students who can think from their mind and write in the answers in O levels, that is not allowed. In case if you like avoid 2-3 steps and write in the answer by your mind, most probably your teacher or your sir or madam might say, don't do this because you won't be getting marks in your O levels. Because in O levels, normally you get marks for the steps, for the simplification steps. But in A levels, that's not in that way. In A levels, only marks has been allocated for the logic, which means the thinking part. Certain amount has been given for the simplification and for your final answer. The main marks has been allocated in A levels for your logical thinking or the thinking part. So in A levels, if you directly write this simplification, if you are really good in simplification, it's totally correct. Your marks won't be like deducted for not writing these steps. Okay, so make sure if you're good in simplification, don't like skip steps and even do the simplification wrong. You can only do that if you are really sure and confident about your simplification. If not, you can go step by step and still do it this way. Clear? Okay. Okay, then do question number 9 and 11. Do question number 9 and 11. We have the sixth power, but we have dealt with it before. You can remember when we were doing the difference of two squares. I told you how a sixth power can be written. When we were doing the difference of two squares, I told you how the sixth power can be written as 2 cubes. Question number 9 and 11. So can't we simplify further, taking it as a quadratic expression? Now, if you can simplify anything further, do that. That is okay because I have limited to here. But if you see that this can be even factorized furthermore as a quadratic expression, you can do that. I don't think whether they have factors here, but if you can see the factors, I'm not sure whether we have factors, but if you see the factors, you can do that. Whenever you see a further simplification or a further factorization, do that. Because normally in factorization, we are supposed to keep the answers in the simplest form. Good, no? Ask questions in that way in the online class even. Okay, so here, 6 power. Tell me, how can we write the 6 power as a cube? A squared cube. Using the power of a power. No, you can write the 6 power as is A squared cube. A power of a power. So what is this concept, the simplification? We call it as power of a power, which we have learned under indices. Power of a power. Okay, so now you can clearly see the two cubes. So here, this plus this, which is a squared plus b squared, okay? A squared plus b squared. And then we have to consider the square of the two terms together with the product, plus b squared. Clear? We need to consider the square of the two terms. We need to consider the square of the two terms together with the product of the two terms, which gives you the final answer. A squared plus b squared into a to the power 4 minus a squared b squared plus b to the power 4. We have a to the power 4 minus a squared b squared plus b to the power 4. Plus b to the power 4. Okay, so when you're doing question number 11, I'll give you more time. Think what is the basic step of factorizing. If you can't remember, think what is the basic step of factorizing. What is the first step you're supposed to do in factorizing? Think when you're doing question number 11. When you're doing question number 11, think what is the basic step of factorizing. What are you supposed to do first? Okay, tell me what is the basic step of factorizing? First step of factorizing. Tell me. If there are any common factors or common terms, you need to take it out. That is the very first or the basic step of factorizing. If you see any common terms, take them out. Okay, here it's, you can see a squared is common. So when you take out a squared out, we have 64. When 2 is taken out of 5, 3 is remaining. So we have a cube. Okay, that is how you get the addition of 2 cubes. So the basic step of factorizing is the common term should be taken out. And we have b cube. 64 is the cube of 4 and a cube. The basic step of factorizing. And so we have b cube plus 4a cube. Good. And now apply what we learned today. A squared into b plus 4a. B plus 4a, and we have the square of the two terms together with the product. We have the squares of two terms together with the product. So a squared b plus 4a, b squared minus 4ab plus 16a squared. 4 squared is 16 and we have a squared. So this is how you can do this. Clear? So when you have to factorize an expression, the very first thing that you need to check whether you have any common factors, because that is even the easiest way. Now in this case, if you don't take out the common term, you won't be able to see the addition of 2 cubes. But let's say even without taking out the common term, still you can factorize an expression. But always keep in mind, if there are common terms, taking out the common term is the easiest way that you can do it. Like let's say you can factorize even without taking out the common terms, but still, if you take out the common terms, that will be the easiest way that you can factorize it. Okay, so because normally in factorizing, we expect to keep the answer in the simplest form. Okay, okay, then complete this one, and then let's move on to the next topic. Wait, let's write something here. Complete the work. I'll give you like 1 minute. Complete this. If anyone who haven't taken the answers yet, complete the work. Okay, then come to this one. Come back to this one. And here I told you to box these using a dotted line. Put a red arrow here and red star mark and write in a normal pen. Near this one, put a red arrow, red star mark and write in a normal pen. Write this. This expansion is even used. This expansion is even used. This expansion is even used for the addition of two cubes. This expansion is even used for the addition of two cubes. Addition of two cubes. Okay. Okay, then write the next topic. Algebraic expansion for the algebraic expansion for the algebraic expansion for the difference of two cubes. Algebraic expansion for the difference of two cubes. Algebraic expansion for the difference of two cubes. Okay. So same thing will be repeated, but here we will be considering the cube of a minus b. Here we will be considering the cube of a minus b. So we have a minus b cube. We have a minus b cube, which is equal to the same set of terms that we have written previously, but you can remember the sign comes as a battery, plus minus, plus minus. Battery means that is how you this connect the batteries in a series way, no, plus minus, plus minus. So here the same terms will be coming a cube, 3a squared b, 3ab squared, and b cube. But the sign comes as plus, minus, plus, and minus. Okay. Now these are the two terms that I need to isolate. I have a cube and minus b cube. I need a cube and minus b cube. So here I need to isolate those two terms. So this will be taken to this side. We have a minus b cube. Minus becomes plus 3a squared b, plus becomes minus 3ab squared is equal to this a cube minus b cube. So this is what we need to factorize. So same thing, I'm not going to change the side. It's just flipping the equation. I'll write this from this side. We have a cube minus b cube is equal to a minus b cube plus 3a squared b minus 3ab squared. So then I'm going to factorize this. So then I'm going to take out the common term of the two terms. We have 3ab common. So taken out, it's a minus b. So similar to the previous one, this is not a factorization. Why? Why is this not a factorization? I just mentioned. Why is this not a factorization? Because this is not a product. If it is a factorization, you need to keep it entirely as a product of terms. There can't be these plus minus terms. should be a product entirely. But this one is even used for the expansion of the difference of two cubes. So let's even box that using a dotted line. So later you can write that it will be used. And then I'll factorize this furthermore. We have a cube minus b cube is equal to, pull out a minus b. We have a cube, we had a cube, one has been taken out, then we have a minus b squared plus 3ab. Here we have a minus b. Now expand this, we have a squared minus 2ab plus b squared plus 3ab. Which means I have a complete factorization for the difference of two cubes. It's equal to a minus b, a squared minus 2 plus 3 is plus ab plus b squared. So now it's clear. You get the same set of terms. You get the same set of terms, but only change is the sign. No? So here we have a cube minus b cube, same thing. A minus b, the square of the two terms together with the product. So here, can you ask me the question, sir? Here we have a minus. So why did this become plus? Can I give a logical explanation for why did this become plus? No, there's no any logical explanation. Why did I get a plus? Because when you simplify minus 2 plus 3, it's plus 1. So this is entirely a simplification. Okay, not a logical thinking here minus plus. No. So same set of terms we get a cube minus b cube is equal to this. Okay. Hands up if this one is clear, this part is clear. Hands up. Okay, good. Then write in the same way. Let's factorize the difference of two cubes. So when I ask whether you understood, even online students are supposed to answer. At least send a hands raising emoji or yes or anything. I need a feedback. Huh? Okay, let's factorize the difference of two cubes. The difference of two cubes within brackets a cube minus b cube within brackets a cube minus b cube using the expansion of a minus b cube using the expansion of a minus b cube using the expansion of a minus b cube. Okay, write the expansion, isolate the difference of two cubes and then factorize it. Do it in the same way. Do this in the same way, similar manner. So we will be learning 4 new expansions today, 3 new expansions, and even this simultaneous equation part will be a new part. So all the 4 work that we are doing today are new work, which you haven't done in O levels. Okay. Okay, then the same shape. We have a cube minus b cube. It is a minus b, and we have the same terms, but all are plus. The square of the two terms together with the product of the two terms. You can write it and box it. And I'll do two examples. Question number 1. We have x cube minus 1, which is equal to x cube minus 1 cube. And then this is equal to x minus 1. Write in this way the square of the two terms into x into 1. And then I have x minus 1, x squared plus x plus 1. I have x minus 1, x squared plus x and plus 1. Okay. So question number 6, we have 27 x cube minus 8. Okay. First look at the board and then you can do the questions alone. 27 x cube minus 8. Focus, focus, look at the board. Then I'll give you some work to do alone. First learn properly and then you can do it, practice. Okay, so 27 is 3 cube and 8 is 2 cubes. So we have the difference of 2 cubes. We have the difference of 2 cubes. Now this is equal to 3x minus 2. And then consider the square of the two terms together with the product 3x into 2 plus 2 square. Consider the square of the two terms together with the product of the two terms. Okay. Then we have, to simplify this, it's 3x minus 2. And here we have 9x squared, 6x plus 4. 9x squared, 6x plus 4. Clear? So that is how you factorize difference of two cubes. Okay. Write this one, box it properly using a red pen and then do the two questions on the board and do 7, 8 and 12. Do the two questions on the board and do 7, 8 and 12. Question number 7, we have x cube, y cube minus 27, which can be written as xy cube minus 3 cube. Here we have the difference of two cubes. And this is equal to xy minus 3. And consider the square terms xy squared plus the product into 3 squared plus the product into 3 squared. So then we have xy minus 3 x squared y squared plus 3xy plus 9. Okay, so this is how we can factorize this. And then question number 8, we have a to the power 6 minus b to the power 6. Now we have worked with this, not something new. So first you can write this as a squared cube minus b squared cube. Here we have the difference of two cubes. And then you can factorize this. You can factorize this. This is equal to this minus this. So a squared minus b squared. This minus this, a squared minus b squared. And we have the square root of the two terms plus the product plus b squared squared b squared squared. Okay. Okay, here now I told you what we expect when you factorize is to keep this in the simplest format. So you can simplify this inside, but here we have a squared minus b squared. So this one can be furthermore simplified. So when you can see, that's why even when I was answering the question from the online class, in any expansion or any factorization, if you can see a further simplification, you don't have to ask me to do it. You can do it, and it's better if you can do it. So here you have the difference of two squares, which means this one can be further simplified a minus b and a plus b. This can be further simplified a minus b and a plus b, and here it's a to the power 4 plus a squared b squared and b to the power 4. We have a minus b, a plus b, and in this way. Okay. Okay, then question number 12. What we have is 8, no, x cube minus 8y to the power 6. We have x cube minus 8y to the power 6. Okay, so how you can write this? We have x cube. 8 can be written as 2 cube, and y to the power 6 can be written as y squared cube. That we know now. Now 6 power is not a new thing for us. We know it can be written as a cube of a square, which means x cube are 2y squared cube. So these are the two terms. That's all. Okay, now if these are the two terms, we have to consider difference x minus 2y squared, and then consider the square of the two terms together with the product plus 2y squared squared, which gives you the final answer x minus 2y squared x squared plus 2xy squared. 2 squared is 4, 4y to the power 4. Because when you consider square of y squared, it's y to the power 4. Okay, hands up who have written these three correctly. Question number 7, 8, and 12, even in the online class. Okay, good. Now do question number 10. When you're doing question number 10, make sure you follow the basic step of factorizing. Do question number 10. Make sure you follow the basic step of factorizing. So I need even online class students to answer who got the answers for questions 7, 8, and 9. I need everyone to answer. Okay, everyone should send a message in the chat. Make sure you keep the chat engaging. Not only 1, 2, 3. If you have taken the answer properly, just a small message. Got it is even enough. To question number 10, and make sure you follow the basic step of factorizing. Okay, so I told you the basic step is if you can see any common factors, you are supposed to take them out. So here 80 is common, and inside 216 there are 27 eights. So 80 is common. So when you take out 8, it's a cube minus 27 b cube and c cube. Which means this can be expressed as a cube. 27 is 3 cube. So 3bc cube, which gives you the difference of two cubes. Here we have a minus 3bc and a squared plus a into 3bc plus 3bc squared plus 3bc squared. So then I have 8 a minus 3bc. We have a squared plus 3abc plus 3 squared is 9, 9b squared, c squared. So this is how we can do this. Okay. But here I ask you to do the basic step of factorizing, which means taking out the common term. Let's say in a normal question, you didn't see that there are common factors, but still you are supposed to end with the same answer. Because I told you taking out a common factor makes your simplification easier, but that is not a compulsory step. There's no any rule in maths that you need to take out the common factors. I ask you to take out the common factors because that makes your simplification easier. But let's say that someone is doing this without taking out the common factors. How he or she can do it? 8 can be written as 2 cube. A is a cube, okay? 216 is the cube of what? 636, 316. So 216 can be written as the cube of 6. Okay, now we have 2a cube minus 6bc cube. Okay, here it's 2a minus 6bc, 2a squared plus the product of the two terms plus 6bc squared. 6bc squared, which means this is equal to, and again you can take out a 2 here, because if you want to have the simplest form, you're supposed to keep it in the simplest form. Everyone's simplest answer should be the same. Okay, so here you can see 2 is common taken out. And here when you simplify, it's 4a squared plus 12abc plus 36b squared c squared. Okay, I have already taken a 2 out. A minus 3bc, can say, yeah, in the next term, What is common? 4, 12, 36. 4 is common. We have 3ABC. And when 4 is taken out from 36, it's 9B squared, C squared. Which means the final answer should be the same. 2 into 4 is 8. A minus 3BC, A squared plus 3ABC plus 9B squared, C squared. Clear. So that's why I told you, like, taking out the common factor is not a compulsory step, but it makes the simplification easier. So initially, when you take out 3, here these are like terms that which consist of less number of simplification, but here you have some work to do, no? You have some work to do, but at the end, simplest form should be the same answer. Is it clear? Okay, hands up who is clear with the difference of 2 cubes and addition of 2 cubes, everyone. Good. I'll give you 1 minute, drink some water, and if there's anything to complete the work. Okay, write the next topic. Trinomial expansions. Write the next topic. Trinomial expansions. The next topic is trinomial expansions. Okay. Okay, so previously we have done this binomial expansions. So I told you when it is a binomial expansion, this prefix bi, bi stands for the term 2. Because normally bicycle means like it stands for like there are 2 wheels in a bicycle. So that's why we call it as a bicycle. And binary means like all these stands for 2. Similarly, this prefix tri stands for 3, which means if it is a trinomial expansion, now we know we are referring to an expression which consists of 3 terms. We are referring to an expression which consists of 3 terms. Okay, now here what we are going to do is we are going to write an expansion for the square of a plus b plus c. Now this is what I'm going to do. I'm going to write an expansion for the trinomial a plus b plus c. So this is a trinomial. An algebraic expression consist in three terms is known as a trinomial. Last week we did an algebraic expression consist in two terms is known as a binomial. Clear? So binomial, and here we have the trinomial. Okay, now what we are going to do here is write an expansion for the square of a trinomial. Square of a trinomial. Okay, first let's write in this way. An algebraic expression, an algebraic expression consisting of three terms, consisting of three terms is known as a write in a black pen, trinomial is known as write in a black pen, trinomial. Trinomial. Okay. Okay. Write in an write in an expression. Write in an expression. Write in an expression for the square of a trinomial. Wait. Write in an expression for the expansion of the square of a trinomial. I'll repeat it. Write in an expression for the expansion of a square of a trinomial. For the expansion of a square of a trinomial will be discussed in this section. Will be discussed in this section. Will be discussed in this section. Okay, so now what I'm going to do is I'm going to write an expansion for a plus b plus c squared. Okay, now how many terms we have here? Here we have three terms. We have three terms. Okay, so I'll tell you an interesting story in maths. I told you maths should be done in a way that maths can be do, not in a way that other subjects can be done. So what is the meaning of that? In maths, we are using a limited number of things that we need to memorize. We need to use. We will be using a minimum number of things, these theories or equations that we need to memorize. So in maths, what we do is, let's say we have a problem that we don't know. Okay, a simple example, let's say we have a problem that we don't know how to solve. I don't know how to solve this. In this case, I don't know how to expand this. So if you have a problem which cannot be solved or which cannot be expanded, what you are supposed to do is you need to bring down this equation or bring down this problem to a position which can be solved. You need to bring down this question or the problem to a position that you are convenient or you are comfortable to solve. So that is something we do in maths. Not even in maths, even in the general life you do that. Let's say that you come to you go to one goal face. That is the most prominent city center or the place that normally youth, school children and all are spending, Colombo children are spending their leisure. Either it's one goal phase or CCC, and now you have the HCC, the Havelock. No, it's not the HCC, Havelock Mall, HM. Okay, so you have the Havelock, most probably it's like the OGF or the CCC or Havelock Mall. In our days, I think I spoke about this. In our days, when I was doing A levels, it used to be the MC, Majestic City, which is in the Gall Road, and Excel World. Like it's like you are you are Aya if you go to Excel World. That way. In now you are Aya and Akkas if you go to one goal phase. Okay, that is the prominent one. And you enter the one goal phase and you see a significant landmark. You see a significant landmark. Let's say you see a no limit outlet there. And then you're roaming around the one goal phase, the city, the center, and you get lost. You get lost. I know nowadays you don't get lost. And now you can't use Google Maps to find the location. Because if you use, can you find the location using Google Maps when you are inside a building? No, you can't do that. Like Google Maps doesn't show that you are in this floor, you are going this way. No. Google Maps itself shows just the one golf face mall. So then what you normally do, somehow you are trying to find that landmark. No. You are trying to find that landmark because you know when you come to this no limit showroom, you know how to exit from that place because you remember you were coming into the mall and you saw this the no limit showroom. So that is registered in your mind. And when you get lost inside the shopping mall, your first intention is to somehow reach to that no limit. Even when you're asking from someone, you might ask how to go out, but you will be asking where is the no limit. You're like it's a bit shy to ask how to go out. You go to one golf face and you're asking someone how to go out. Okay, so you feel a bit shy, so you're asking the question, where is the no limit? You are not telling her that I don't know how to go out. You are telling how to go to no limit. And then when you go to no limit, you know how to exit the shopping mall. So what did we do in the general life scenario? When you are in a position that you don't know, when you are in a position that you feel lost, you somehow try to come to a position which you are comfortable with. You try to come to a known position. You try to come to a known position. I'll take another example. Let's say a driver is coming from Gaul. From Gaul, he's coming in the highway and he exit from Kottava. I need to pay attention. I can't have different chats when I'm talking. I'll give you like 1 minute and I'll give you an interval to have these other chats. That's why I'm giving. In this class, I just told you I'll give you 1 minute to complete the work and drink some water. But in the 2027 and 26 classes, I say I'll give you 1 minute to drink some water. And if there's anything to talk, you can talk. In this class, I won't say because in this class, you don't have that much to talk. No. 2027, 26 students they are stressed, so much of workload. So they have the weekly gossip loaded to talk. So I need to give chances. No. Let's say there are two friends, they are only meeting in this class. So as a tutor, I'm responsible to give them a chance to talk and just share all these gossip that they have been loaded for a week. No. So I have to give that chance. No. If not, like if the class starts by 3 o'clock, you can come by 2:30. I think students are allowed to come in by 2:30 and you have ample half an hour to talk. But from my end, if a student won't be able to come early, it's my responsibility to make sure that they are unloading all the gossip during this 3-4 hours. So I'll give a proper interval and I'll be giving intermediate 1 minute, 2 minute breaks to make sure that all the gossip are unloaded. Because it's really bad if you leave the class with half of the gossip unloaded. You have been waiting till this moment. If you are meeting in another class, that is okay. Okay, so I can't see anyone talking when I'm talking in the mic. And when I have given to solve a problem, I can't see anyone talking. You can do anything, like being honest, if you have completed a problem that I have given, and if I see a student watching his mobile phone, I won't respond or react. I'll just ask him, like if I see someone is watching the mobile, like he's looking, he's just doing something in the mobile phone. If I see the eye contact, I'll be asking, done. If you say yes, that's okay because that is not a burden for the class. That doesn't mean that you are okay to use the mobile phone on and off in the classroom. But I don't respond if he has completed the problem and using the mobile phone, which is not a burden for others. But better to not to use the mobile phone because when you use it, your focus goes away. You see all the notifications and you all are so addicted to the mobile phone. Even without getting the mobile phone, at least once in 10 minutes, you feel to go to the mobile phone and just look at all the apps, whether you have seen it. Even though there's no any notification, naturally, once in every 15 minutes, 10 minutes, you take the phone and just go to the apps and see, notification, whether the notification hasn't come by mistake, but whether there is a message or a call. Okay, so because that's why when you look at the phone, the focus goes away. So that's why I don't like when you look at the phone. But make sure when I'm talking from the mic or when I have given the chance to solve a problem, I need the pure attention, 100% attention to the class. Okay, so my example was like, let's say a lorry driver is coming from Gaul and he exits the highway from Kottav, which is ideally Makumbura, let's say Kottav. And he come to somewhere in Nugegoda. The job is done. Now in Nugegoda, his job is done. On the way back to Kottav and Gaul, let's say he get lost somewhere in Maharagama. And the lorry driver stops near the road. And will the lorry driver ask someone outside, how can I go to Gaul from here? He came from Gaul. But will he ask the question from the one outside he just met? How can I go? Like, how can I go to Gaul? කවදර යාල් දෙනවද පාර යන එක්කෙනෙක් මේ බදුල්ල යන්නේ කොහමද කියලා. ගාල් යන්නේ no. The most like the question he will be asking, the obvious question is, how can I go to Kottava? Because somehow if the lorry driver goes to Kottava, he knows how to go to Gaul from Kottava. So even in that general life scenario, what we have done, we have come to a place that which is comfortable and which I know. So that is the only thing. And I even have a similar life experience when I went to Thurston College before scholarship, and after scholarship I went to Ananda College. And when I was going to Thurston College, that was quite okay because only one bus, which we were going in the 138 route, and one bus directly from our place we can go to Thurston in the morning. We means me and my two brothers, elder brothers, and even since I had two brothers, things were okay. Just directly we went to Thurston. And even on the way back to home, we have to walk to Tumulla Junction because the road is one way, and then take the same bus back to home. But when I went to Ananda College, it's the route is quite different. So I can remember the very first day when my mother was taking me to school, she was like teaching me how to take the bus, not take the bus, the normal bus. Okay, we have to get down from Nukegoda and you have to walk towards this Bothri. I can't remember whether we had the flyover back then, but let's say we had the flyover. So my mother was asking me, you have to get down from this halt and you have to walk towards the Bothri, the other halt, and you have to take the bus 176. 176 is the bus Haragampiti Hettiyawath, and you have to take tickets to Ananda College and you can get down near your school. So she explained me the process, and even in the very first day, she took me to school. And after the first day ceremony of these all new students, and back home, even same way, she explained, okay, when you're coming back from this is where you have to take the bus, 176, and you have to get down from Nukegoda. So what comes to my mind when it is Nukegoda? The BOC, the Boatry, the no limit, and the flyover. So that is what I know when I see Nukegoda. When Nukegoda comes to my mind, this is the place. When I see a flyover, BOC, Boatry, no limit, then I know it's Nukegoda. Okay. Now only you have a flyover in Kohuala, even in the next junction, but that was open last year, 2024. No? So first day, okay, went with my mother, Amma, and then next day I went to the school alone. Going to school was okay. Then after school, I got into this 176 bus, and I bought a ticket for Nukegoda. And then suddenly the bus stopped. And the conductor was telling, Nukegoda Bahina. And I was waiting because this is not the Nukegoda I know. I was looking for a BOC, I was looking for a Boatry, flyover, nothing. And then I was like grade 6, no, small like this. Yeah, somewhere here. Like somewhere here. And I was waiting in the bus, expecting that I'll be reaching the Nukegoda I know. Then the conductor told me, Puta, bus is over from here, you need to get down. Then I can't say, no, where's the BOC, where's the Boatry? And I just got down from the bus. And then I was looking over, still I can't see, this is a totally unknown place for me, and what can I do? So first thing that comes to mind when we are in a trouble, when I was schooling, is that the first person comes to mind, even who is the first person that comes to mind when you get scared of? It's like most probably your mother, no? Not the neighborhood auntie, no? The one that first comes to your mind when you are in a trouble is your mother. So then, back then, we were not using mobile phones, and even grade 6, I didn't have a mobile phone even, and even mobile phones were not that prominent when I was in grade 6. I'm not talking about these 1990s. It was in the recent these 2000s. But mobile phones were not prominent in the country. So, but we had these telephone booths. Nowadays, in some schools, you can see this telephone booth where you can put coins, and hands up who have seen the telephone booths. Okay, luckily everyone has seen it. Even you are from the generation, last phase of generation Gen Z, but still you have seen it. So in school, we had this telephone booths. During schooling periods, like we had a nice time during our free periods where we were going for these telephone booths with a bunch of friends, put in coins and dial in random numbers. And if someone asks, we just ask, okay, can you check whether water is coming? We are from the water board. Can you check whether the current is coming? We are from the electricity board. and Dane Baragatta Kiyala, like as a talking as a monk, whether you like why aren't you coming to the we were having a good childhood time when we were like grade 9, 8, 9, 10. And once I can remember, we call as a Pizza Hut person and asking that you have the person you have already purchased this pizza 14,700 and we are in front of your house, and that person was totally surprised. I don't even have that money, that much of money in my bank card. Like nice time, nice period. So that's how we used to spend some of our free periods. So then we had this telephone booth in I saw this telephone booth in Ugegoda, but now I don't think in the public roads we have telephone booths. Now it's very rare to see a telephone booth in a public road, no, because most of the people got mobile phones, no. So I saw a telephone booth and I went and dialed the home number and called them. And I called, I was telling Ammi, I got down from this place, which the conductor, like he says that this is Nugegoda, but this is not Nugegoda, what I know. And I was asking, what can you see? And when I look around, I saw a huge yellow building, which was the supermarket. Okay, the market, it's not super, but we call it as the supermarket. So I saw that market. I can see a huge, I can see a huge yellow building. And then Amber told me, okay, just come forward. Like I can't come with the telephone booth, but she was giving me directions. Just walk forward, and you can see the junction. Turn right and keep walking, and then you will pass the railway crossing, and still keep walking, and then you will see the flyover and the BOC. So what has happened is there are two 176 buses. One is Karagampiti Hettiavatta, which comes from the Dehivala area, and the other one is Nugegoda Hettiavatta. So I'm supposed to get into the Karagampiti Hettiavatta one, because the Nugegoda Hettiavatta one is starting from that the place that where I got down. Then mother told me, okay, come here, then you will see the flyover. So that's Nugegoda, then you can come. But she didn't give me instructions to come home. She gave me instructions to come to this Nugegoda junction, because she knows that if I come to Nugegoda, I can come to home. So same thing. What the instructions she gave me, she was asking me to come to this place which I know. So that is how we act in a general life scenario. Now what I want you to do is, I need you to apply this same concept, not the Nugegoda concept. When you have something in your life which you are unknown of, try to bring it down to a position which you know. Okay, look, I'm going to apply it in here. Here we have the expansion of 3 terms. But what do I know? What do I know regarding expansions? We know binomial expansions. I can expand the square of 2 terms. So what am I doing here is I'm writing this as the expansion of 2 terms. So I'll take this a plus b as 1 term and c as another term. So here we can see 3 terms, but here we can see only 2 terms, because a plus b has been considered to be 1 term. A plus b has been considered to be 1 term. Okay, now tell me just tell me the shape. What is the expansion of a binomial? A plus b squared. How do we do that? A plus b squared. Don't just repeat the expansion. A plus b squared. We have the square of the 2 terms. We have the square of the 2 terms together with 2 times the product of the 2 terms. So that is the shape. We have the square of the 2 terms along with 2 times product of the 2 terms. Okay, here, apply that here. So square of the 2 terms. So this a plus b is considered as 1 term. So the square of this term, a plus b, is considered as a square of 1 term. So the square of a plus b. Clear? So a plus b is acting as a single term. Is it clear? A plus b is acting as a single term. Plus the product of the 2 terms into 2 into a plus b into c, 2 into a plus b into c, plus this squared, plus this squared. Clear? So what I have done here, a plus b is considered as 1 term. So here a plus b is the single term. A plus b is the single term. So then I have a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. This is something we know. Expand this using your basic maths knowledge. 2a into c is 2ac. 2b into c is 2bc. and we have c squared. 2a into c is 2ac, 2b into c is 2bc. Okay, so now if I rearrange this considering the same set of terms, first write the squared terms a squared, b squared, c squared. And then we have 2ab, 2ac, and 2bc. We have a squared, b squared, c squared, and 2ab, 2bc, 2ab. Okay, so I told you, whatever the expansion we write, there is a shape that we can keep the shape, like we can keep in mind. We don't memorize it. Even here, there's a shape. Look at this. What is the shape here? What I have considered is the expansion of a plus b plus c squared. So what we have here, tell me what we have here. The square of the terms. No, we have the square of the terms. We have a squared, b squared, and c squared. We have the square of the terms. And then we have 2 times the product of the terms pairwise. Product of the terms pairwise. What do I mean by pairwise? A and B is multiplied, A and C is multiplied, and even B and C is multiplied. So here we have 2 times the product of the terms pairwise. A into B, A into C, and B into C. Okay, so then we have 2 times the pair of the terms 2AB, 2BC, and 2AC. So this is the trinomial expansion of A plus B plus C squared. Okay, so just keep the shape in mind. We have to consider the square of all terms, and we have to consider 2 times the product of the terms pairwise. Okay, so here, what is a plus b plus c squared? This is the square of the terms. This is the square of terms. This is the square of terms, and these are the product of the terms pairwise. Pairwise product of terms. Pairwise product of terms. It comes with a 2. It comes with a 2. Okay. Pairwise products of terms. Clear? So what I have done, I have considered a trinomial as a binomial and expanded this. Okay. Write in this way. Write in this way. Let's write the trinomial. Let's write the trinomial as a binomial, as a binomial, as a binomial, and consider the expansion. And consider the expansion. And consider the expansion. Okay. Okay, then do this. Write these properly so you have understanding what we have done here. Here we have 3 terms and here we have 2 terms. So what I have written here is square of terms and pairwise product of terms. Okay. Okay, so now let's see how we can apply this in a normal expansion. I'm referring to, so I'll go with the exact number. Question number 5, sub question 3. Okay, question number 5, sub question 3. Okay, so what happens here? We have the expansion of this. No, so this is what you have to do. Okay, listen. Okay, wait. You can do, there are so many questions you can do alone. I told you, first learn properly and then you have to practice that and apply that. Okay? Okay. Okay, so first we have to consider the square of the three terms. Okay? A squared, 2b squared, 3c squared. And then consider the product pairwise, but you have to go with the 2. 2 into a into 2b, 2 into a into 3c, and 2 into 2b into 3c. So that's how we consider the product pairwise. 2 into a into 2b, 2 into a into 3c, and 2 into 2b into 3c. 2 into 2b into 3c. Okay, so then I have a squared, 4b squared. Then it is a matter of a simplification plus 4ap, 6ac plus 12bc. So after writing the first step, then it is a matter of a simplification. Even in this case, if a student is confident in his or her simplification, directly writing this answer is totally fine. Okay, it's totally fine if you're sure about your simplification. Clear? Okay, hands up who understood the trinomial expansion, this a plus b plus c squared. Good. Okay, then do questions 1. The first one is already done. Third one is on the board. Do question number 1, 2, 3, 4, and 6. Do the questions 1, 2, 3, 4, and 6. So I can see some are just copy pasting the board, blindly copy. No, that is not how you are supposed to do that. Get the help from the board, that is okay. That doesn't mean you have to repeat the board line by line. It's okay if you do anything wrong, but make sure you learn and do the next one properly. So question number 1, 2, 3, 4, and 6. And meanwhile, the online students, can you send a message in the chat mentioning from which district you are from? just to have a understanding from which district that you are from. Not you all, I mean the students who have joined online. Send a message mentioning the district. Okay, good. We have a combination all over the island. We have Colombo, Kegol, Gampaha, Matale, Kandy, Monaragala, Gol, Jaffna, Kurunagala, Puttalam, Mena, good. Madulla, Colombo, Gampaha. Good. Okay, so question number 2, we have a plus 2b plus c. So first write the square of all terms, a squared 2b squared plus c squared. And then consider the product pairwise 2 into a into 2b, or 2 into a into c, and 2 into 2b into c, which gives me a squared plus 4b squared plus c squared plus 4ab, or 2ac plus 4bc. Okay, so this is what we get. And then we have 3x plus 4y plus 2. So it's 2, so 3x squared, 4y squared, 2 squared, which is, sorry, we have to write the other terms. 2 times the product pairwise 3x into 4y, 2 into 3x into 2, and 2 into 4y into 2. Which gives me the final answer. We have 9x squared, 14y squared, 2 squared is 4. Here it's 2 into 3 is 6, 6 into 4 is 24, 24xy, and 2 into 3 into 2 is 12x plus 16y. We have 16y. Clear? Okay. And then the expansion of a squared, ab plus b squared is equal to first the square root of each term plus b squared. Then consider the unit-wise product, sorry, not unit-wise, pair-wise, a squared into ab, 2 into a squared into b squared, and 2 into ab into this, 2 into ab into b squared, which means a to the power 4, a squared b squared, b to the power 4. 2 times a squared into a gives you a cube. A squared into a gives you a cube. 2 times a squared b squared, okay? And 2 times a b into b squared gives you b cube. So we have 2ab cube. Okay. Hands up who have done all these three expansions properly. Okay. Then better to do this in a handbill or a rough paper. Do question number 7 or use a pencil. If you are sure that you can do it using a pen or do it in a pencil or the last page of the book or use a rough paper or a handbill. Question number 7, because there's a minus in it. Question number 7. Okay, even online student sent me a message who got the answer. All three expansions for this. Okay. Now, this is what ideally happens here. You have a minus b plus c squared. So, what do I know? I know the expansion of the three terms when it is plus. When you have this plus this plus this, you know how to write the expansion. So what ideally happens here? So the same thing, same example. If you are in a position that you don't know, somehow we have to write this down or we need to bring this down to a stage that which you are convenient of. So here what happens is that I can write this minus b as plus minus b. So I'll just show you what happens here, but then I'll tell you how to write this directly. So what happens here, this minus b can be written as plus minus b. That we can write minus b as plus minus c. Sorry, plus minus b. Plus c squared. Okay, now this is what we have done so far. We have three terms, and how can you write the expansion? Square of each term, and then 2 times the product pairwise 2 into a into minus b, 2 into a into c, and 2 into minus b into c. So here I have considered this minus b. What I have considered here is minus b. So minus b has been treated as plus minus b, and that is how we expand this. Then you get the final answer. Minus, when you square it, it's positive, plus b squared plus c squared, a minus 2ab plus 2AC and minus 2BC. Minus 2BC. Okay. Okay. But when you just expand this, you don't have to write this in this way. You can easily do this. A small thing. So this is what you're supposed to do. We have A minus B plus C. Okay. Now look at this. So when you have minus, that's okay. When it is squared, all the terms become positive. Even though these terms are minus, when you square it, all the terms are positive. So what can you write? A squared, B squared, C squared, that's all. Plus, plus, plus. Okay? And then when you consider 2 times the product pairwise, tell me plus into minus is minus. No, that is something you know. 2 times the product wise pair. So minus 2AB. 2 times the product, the pairwise product, 2 into A into C is plus 2AC. And this one, 2 into minus B into C is minus 2BC. 2 into minus B into C is minus 2BC. Clear? So that's how you can write it. Directly write it. You don't have to write in this way. I just wrote this to show you what actually happens here. So what actually happens here is this one, but write in this is more than enough. I'll do the next example. So I need you to give me the answer. A minus B minus C square. Okay, now tell me. What do we have the first 3 terms? What are the squares? Tell me. Look at the board. Tell me. Tell me. Tell me. Talk. So look. What do we have? A squared, B squared, C squared. And then you have to consider the product pairwise. 2 into A into minus B minus 2AB. A into minus C minus 2AC. But minus into minus is plus 2BC. Plus 2BC. So this is how you write this. Okay. Hands up who understood this one. Okay, good. Then to 7, 8, 9, and 12. 7, 8, 9, and 12. So the remaining questions, you have to do that at home. Remaining questions, you're supposed to do them at home. After these two, to question number 9 and 12. Do the work 9 and 12. This is good. And this is what I expect in the online class chat. When a student asks a question, I see like another student has answered that. Good. That is what I expect. Somebody's asking what are the questions do we have to do, and some mails has answered. Good. Keep this active and engaging. So then even I will be checking this on and off. Yeah, I see the correct answers even here. Good. Okay, question number 9. First write the squares ignoring the sign: a squared, 2b squared, and 3c squared. You only have to consider the sign when you go this product-wise pair. Plus 2a into 2b. This into this is minus 2 into a into 3c. Again, this into this is minus 2 into 2b into 3c. So then I have a squared, 4b squared, 9c squared, plus 4ab minus 6ac. And here we have minus 12bc. Here we have minus 12bc. Good. Okay, this one, write the squares: a squared, 3b squared, 5c squared. Okay. And then 2 times the product, 2, this is minus 2a into 3b. This is plus 2 into a into 5c, 2 into a into 5c, and this is minus 2 into 3b into 5c, which means this is equal to a squared plus 9b squared, 25c squared, minus 6ab plus 10ac minus 6, 30. No, we have 30bc. We get a 33, yeah, 30. Okay, good, hands up who have taken 9 and 12, the exact two expansions. Okay, good. Okay, complete the work and then let's write a summary and take an interval. So like I did do 3 questions in this one. Question number 5, 10 and 11, you can do that at home. Okay, then try this using a black pen, write note using in this way. Yeah? Using a black pen, write note, and then using a red pen, write this summary of algebraic expressions. Using a black pen, write note, and using a expansion, sorry. Using a black pen, red pen, write summary of algebraic expansions. Summary of algebraic expansion. Okay, so I need you to write these expansions. You like better if you can write them alone, but if you want, you can just refer the book. So we started with a squared minus b squared, difference of two squares. Then we did a plus b squared, a minus b squared, and a plus b cube, a minus b cube. And today we learned 3 more: a cube plus b cube, a cube minus b cube, and the trinomial expansion a plus b plus c squared. Okay, write down these expansions. Better if you can write them alone, but if you're not sure or can't remember, refer the book and write it. Not only these, I need you to write the expansion. Not only these, the expansions. Anyone can write this, no? Write the expansions, go one by one. And we have like good news income in USA, and Iran has decided to get into discussions. And Trump has previously, yesterday, he gave a time period of 48 hours, and he has extended that for 5 days, mentioning that they have had 2 days of comprehensive discussions. Let's see, like hoping for the best. Okay. Okay. So then this is a minus b, a plus b. War will stop somehow, but you need to know how to expand these. A squared plus 2ab plus b squared. A squared minus 2ab plus b squared. And here we have a cube 3a squared b 3ab squared plus b cube. A same thing comes with plus minus b cube. This is what we learned today. It comes as a plus b and a squared minus ab plus b squared. Okay. And here this comes with a minus b. Similar terms but all positive. And here we have a squared, b squared, c squared plus 2ab pairwise product 2ac and 2bc. Okay, so this is difference of two squares. This is difference of two squares. These are binomial expansions. These are binomial expansions. Addition of two cubes. Addition of two cubes. Let's write it this way. These collectively, this is addition and difference of two cubes. Last one is a trinomial expansion. Last one is a trinomial expansion. Okay, write the next main topic. Simultaneous, solving simultaneous equations. Write the next main topic. Solving simultaneous equations. Solving simultaneous equations. Okay. Okay, now tell me what comes to your mind when we just mention the word simultaneous equations. What like normally comes to your mind? Simultaneous equation. Nothing comes. Blank. Because even I got that answer when I asked the question in the online class Friday, because this one like at the initial stages, because we are doing two groups for the single medium class, and later the two groups will be combined, and we are doing a online class separately. So it's like I'm doing this part for the fourth time in the week. We start on Thursday, and then Friday night we have in the online class, and Sunday evening we have the second group of the single medium one, and today is like the fourth time. So when I normally get the responses in the PO online class. So when I ask the question, even in this class, I expect answers. When I say the word simultaneous equations, tell me what comes to your mind. At least something should be coming. Yeah, there are equations. Okay, okay, it's an equation. What else? Simultaneous equations are equations. Good. What else? How many variables are you thinking of? Two variables. How many equations are you thinking of? Two equations. Okay, so when we talk about this word simultaneous equations, what normally comes to your mind is two equations with two variables or two unknown terms. So then you have this xy equals to someone and xy equals to someone, and you say that these are simultaneous equations. But the thing is, there is no any definition that simultaneous equations are two equations consisting of two variables or unknowns. It is just in O levels, we have limited to two variables or two unknown terms. Simultaneous equations basically means a system of equations consisting two or more unknown terms. Not only two, there can be three unknown terms, four unknown terms. I remember in the university in the final year, in the seventh semester, final year, we had a module called neural networks. So in universities, we have modules. We don't have subjects. The reason, now, combined maths is a subject, no. Chemistry is a subject. Physics is a subject. So let's say in universities for a semester, we are studying a part of maths. For example, in maths, there is a part called calculus, which you will be learning um, approximately 13 months after you will be learning calculus. So calculus is a part of maths. So then can I say that calculus is a subject? No, the subject is maths, and inside maths, okay, okay, not fasting. Fasting is over. No, okay, okay. So calculus is not a subject. The subject is maths. Inside the subject maths, we have a part calculus, so we call it as a module. So in universities, we don't have subjects, we have modules. We have modules which consist of a part of main subjects. So let's say in physics, you will be studying about, let's say, a part called mechanics for one semester. And that is a module. It's not a subject. So we had a module called neural networks. And in this model, I remember we had to solve a system of simultaneous equations consisting of 12 unknown terms. We had 12 unknown terms, but there is a different method that we use matrices to solve it. It's a different method, but we used to have 12 variables, 12 unknown terms. So simultaneous equation is not limited for two unknown terms. The definition is a system of equations consisting of two or more variables. It can be 2, 3, 4, any number of variables. Clear? Okay. Write in this way, a system of equations, a system of equations, a system of equations consisting two or more unknown terms, consisting two or more unknown terms. So we started with system of equation. No? So it should be is known as, not on, can't say on, is known as, because we are referring to system. So system is singular. Is known as, write in the red pen, simultaneous equations. is known as simultaneous equations. Is known as simultaneous equations. Okay. Okay. So if we have only one equation and one unknown term, let's say we have x plus 2 equals 1. You have 1 minus 2. You have x equals minus 1. You have x equals minus 1. So when we only have one unknown term, one equation is sufficient to solve the equation or find the unknown term. But now let's say you have two unknown terms, but only one equation. And I have given you one equation, but two unknown terms. I'm asking you to solve this. So if you solve this, you can say that x equals 1 and y equals 1. But you can even say x equals 2, y equals 0. X equals 3, y equals minus 1. X equals 10, y equals minus 8. X equals 1000, y equals minus 998. So here it's clear, when you have only one equation, but you have two unknown terms, you won't be able to get a unique set of solutions. There can be in like so many solutions. We call it as infinite number of solutions. Because of this reason, we say if we want to solve a system of simultaneous equation, clearly understand this. If we want to solve a system of simultaneous equations and get unique solutions. Unique solutions means only one solution. So this is not a unique solution. But I can't say like this cannot be solved because you can solve this. But there are so many solutions. To get a unique solution, there should be equal number of equations and equal number of unknown terms. There should be equal number of equations and equal number of unknown terms, which means if there are two unknown terms, you need to have two equations. If you have three unknown terms, you need to have three equations. If you have n number of unknown terms, you're supposed to have, tell me, solunga. If you have n for no limit, n. If you have n number of equations, you are supposed to have, sorry, unknown terms, you are supposed to have n number of equations to have unique solutions. Unique solutions. Okay. Write in this way. Write in this way. To solve a system of simultaneous equations, to solve a system of simultaneous equations, we need to have we need to have the same amount of equations, the same amount of equations, the same amount of equations similar to the number of unknown terms. Same number of equations similar to the number of terms. Similar to the number of terms. And then write this two unknown terms, two equations. You can see, look at the board. Three unknown terms, three equations are required. So if you have n unknown terms, we need n number of equations to solve and get unique solutions. To solve and get unique solutions. Okay, write this two unknown terms, two equations, three unknown terms, three equations, and n unknown terms. There should be n number of equations. Okay, so let's just remind what you have done for O levels. In O levels, you can remember you had to solve two simultaneous equations consisting two unknown terms or two variables. Okay, then write in this way. Let's solve two. Wait, let's solve two simultaneous equations. Yes, let's solve two simultaneous equations consisting two unknown terms. Let's solve two simultaneous equations consisting two unknown terms which we have learned in O levels. During O levels, which we have learned during O levels. Which we have learned during O levels. Okay, so this is not something I'm going to explain or teach. This is just reminding what we have done. Okay, now look at the board. So this is what we do. So when we have two simultaneous equations, so let's say I'll use the word two equations. To solve this, what do you normally do? You need to take out one unknown term. Using these equations, you are supposed to take out one unknown term. For that purpose, the coefficient of one unknown term should be same. Here, you can clearly say you have y and y. So when you subtract these two, it's clear that y cancel off. So I'm considering 2 minus 1. I'm considering 2 minus 1 to get 3x plus y minus x plus y equals 8 minus 2. I told you when you put a minus expression, make sure that you need to open brackets. You need to put brackets. Plus y minus x minus y is equal to 6. 2x equals 6. And then you get x equals 3. You get x equals 3. Okay. Now tell me, what did you write after this one? After finding one variable, one unknown term, you can substitute that value in one of these equations. Better to substitute in the easy equation and find the other unknown term. But you wrote something new. What did you write? Let's substitute the value of x to 1. Hereafter, don't write those things. Those are the things that you used to do in 2 pink Dekamanil classes. But from here onwards, you don't have to write those words. You don't have to write, let's substitute x in here. No. If you're going to substitute x in the first equation, just write 1. That's all. Enough. You don't have to write that one. This is not a language. No. This is maths is a language, but it is not English or Sinhala. You don't have to write, let's substitute this in this. No. If you're going to substitute x here, I admit in O levels you have to write that. In O levels you are supposed to write that. If I substitute here, x equals 3, just write 1. Okay. X equals 3 plus y is equal to 2. Y equals 2 minus 3. And then y equals minus 1. That's all. In O levels, I remember in the textbook, they had written these answers at the end and use these brackets and keep in the answer this way. No, not necessary. Not necessary. I'll tell you why this is not necessary. Here, and if your simplification is good, look at this. If your simplification is good, 2 minus 1, when you subtract this from this, you can see y cancel off. And 3x minus x is equal to, I need answers. Y cancel off. 3x minus x is equal to 2x. So if someone can directly write it, it's really good. It's really good. So only write in this one, this step, and this step is enough in A levels. But in O levels, you don't even think of writing this minus this is directly 2x. No. You don't even think right in this way. The reason is, I told you, in O levels, your simplification has been restricted. If you write this in this way, your sir or madam might say you won't be getting marks because in the marking scheme, you had to write these ones. So you were not allowed to do the simplification by mind. But in A-level maths, you have given that freedom. In A-level maths, doing simplification by mind, doing simplification using your mind is allowed in A levels, and they have given you the 100% freedom. So if someone solve this, 2 minus 1, write in, okay, y cancel off, 3x minus x is 2x, write in this, and this is more than enough. But I will be writing every step because I'm teaching in a way that everyone can understand. If I just omit these two steps and write this one, there might be few students who won't be able to understand that at the initial stages. Later, like in 1.5 years, 2 years, now in the 2026 class, we are directly writing this. But in the initial days, we need to make sure, even though I'm good in maths, I can't do everything that I know. I can't solve a problem the way that I normally solve a problem using my maths knowledge. Because then you won't be able to understand some of the parts. I need to make sure to come to your level and do it in a way that everyone can understand. So at the initial days, I'll be writing each of these steps. Then everyone can have a clear understanding. But a student who is good in simplification, you can directly do this, get this, answer this, and this. Okay. So what we do normally here is first we have to have the same coefficient. One unknown term should be having the same coefficient, and then by subtracting, or sometimes by adding, you can take it out. Okay. Okay. So one has been taken out. In this one, you get y equals minus 1. I won't ask hands up who understood because I know everyone already know this. Okay. Okay. Do question number 1, 2, 3. Question number 1, 2, 3, 5, and 6. Question number 1, 2, 3, 5, and 6. And make sure you mark the questions you do in the classroom. Then when you go home, you can continue with the other questions. You can do the other questions. Question number 6. 1, 2, 3, 5, 6. Okay, I'll start with question number 2. Better if the online students can send me answers, like for example, you can put 2 and send the x and y values. Okay, so here, first one and the second one, what you can see here is minus y and plus y. So when you add these two, what happens? 5x minus y plus 2x plus y is equal to 9 plus 5. This cancel off. 7x equals 14. So when you divide by 7, you get x equals 2. X equals 2, and then I'll be substituting the value x equals 2 to the second one. It seems to be easier. And then 2 into x, 2 into 2 plus y is equal to 5. 4 plus y equals 5. So y is equal to 5 minus 4. So then I have y equals 1. Y equals 1. Okay. Okay, so this one, an interesting one, I have included this to teach you something. Now look at this. It's y equals 3x and 2y plus x is equal to this. No? Okay, now look at the book. So 90% of the students, when I give this question soon after O levels, what you normally do, you take this 3x to this side and write a new equation that y minus 3x is equal to 0. 90% of the students do this. Okay, hands up who have taken 3x to this side and written y minus 3x equals 0. Yeah, you can see like almost like every student except few, you have taken this to this side and write it. Okay, now tell me, what is the reason that you have taken 3x to this side? What is the reason? Because all maths ask you to. Then tell me what is the reason that you are the one who took 3x to this side. What is the reason? Because the reason is when we are referring into simultaneous equations, what is in your mind? You have a coefficient x, coefficient y equals to someone, coefficient x, coefficient y equals to someone. So this is what you normally know you have solved when the simultaneous equation is in this way. So when you see y equals 3x, why did you take 3x to this side? Why did you take 3x to this side? Then you can clearly see the yx equals someone and yx equals someone. So that is the reason. And then what you can do, you can either multiply this by 2 to have 2y, 2y, or you can multiply this by, tell me, you can either multiply this by 2 to have 2y, 2y, or you can multiply this by 3 to have 3x and 3x. So that is what you normally do. Okay, so if you haven't learned this before, I'll tell you the easiest way to solve this is this. When they have given that y is equal to someone, no x is equal to someone, you don't have to rewrite this in a way that x plus y is equal to this. The reason, you can directly substitute this y equals 3x value in here. You can directly substitute the y equals 3x value in here. So we normally write it in this way from the first one to the second one, but those are not like rules in maths. The meaning, there's no any proper meaning, but what do I write in this way is we have used the first one in the second one. And now look at this. 2 into y, what is y? It's 3x plus x equals 40. You get 7x equals 14, which means x equals 2. Now when you get x equals 2, you can easily substitute that in the first equation to get y equals 3x. So y equals 3 into 2. Y equals 3 into 2. So y equals 6. Y equals 6. So this is how you can easily do it. Okay, hands up who have done this question in this method, directly substituting. Okay, there are few. Not that if you have done in the previous method, it is wrong. It is totally correct. But here, now from here onwards, make sure when they have given, listen. First, listen, like don't wait in a way that on your mark, get set, and you are just waiting to write. Sarah say in 11, yeah, just wait. You are in that position. On your mark, get set. When I turn in this side, no, like first focus, first listen, then you can do it alone. Learn properly. When I talk, when I teach, learn. Then you practice alone. Okay, so always keep in mind when they have given y equals someone or x equals someone, you don't have to rearrange it that way. You can directly substitute it in here. Clear? Okay, so everyone who has done this in the other method, do this in this method. The ones who have done in this method, you don't have to do in the normal method because this is an advanced step. So everyone who have done this in the normal method, do this in this way. Okay, so then this one, question number 5. Here you can't see the same coefficient, so we have to make the coefficient. What you can do is you can multiply this by 2 to get 2b, Because if you're going to make the coefficient of a equal, you need to multiply this by 4 and again this by 3. So more work. No, this by 4 and this by 3. So better to just multiply the first equation by 2. So multiplying the first one by 2, I get minus 8a plus 2b is equal to 52. Is equal to 52. 26 into 2 is 52. So this is the third equation. Now we can see 2b and 2b. So then I'm going to subtract these two. 2 minus 3. I get 3a plus 2b minus 8a plus 2b is equal to minus 3 minus 52. This gives me 3a plus 2b minus is plus 8a minus 2b equals minus 55. So then these two cancel off. These two cancel off. I have 11a is equal to minus 55 means a equals minus 55 over 11, giving me that a equals minus 5. So I have a equals minus 5. And then substitute that in the first one. I'll substitute this in the first one. I have minus 4a means minus 4 into minus 5 plus b equals 26. 20 plus b equals 26, which gives you b equals 26 minus 20. So b equals 6. B equals 6. Okay. Last one. Clearly, you can see plus y and minus y. Clearly you can see plus y and minus y. Add these two. 2027 next year minus y plus 2x plus y is equal to 2029 plus 0. We have 2029x equals 2029. So these two cancel off. And x is equal to 1. X equals 1. X equals 1, then substitute to the second one, which gives us 2 into 1 plus y equals 0, y equals minus 2. Okay, so we just remind what we have learned in O-levels. So all been simultaneous equations consist in two variables. Okay, hands up who got these answers. Minus 5, 6, 1, minus 2, and these answers. Hands up who got this one. Means we have done your O-levels well. Huh? You have done the homework properly during your O-levels. Okay, right. The topic, solving a system of three simultaneous equations. Right, the topic, the main topic is simultaneous equations. Under that, write the subtopic, solving three simultaneous equations. Solving three simultaneous equations. Solving three simultaneous equations. Okay, okay. Now sit properly and focus. Listen that how the way that we are going to solve three simultaneous equations. So even here we will be using, now look at this. What do we have? We have three equations. We have three equations and three unknown terms. We have three equations and three unknown terms. Okay? Okay. So this is what we have. So here even we will be applying that general life concept that what we normally do. We need to bring this system to a system which can be solved. Now tell me, you know how to solve two simultaneous equations with two variables. You know, like what we have done so far, when we reminded this, you know how to solve two simultaneous equations with two variables. That you know. So what we do here is when we have three simultaneous equations consisting three unknown terms, I need to reduce this system. I need to reduce this system up to two equations consisting two unknown terms. Two equations consisting two unknown terms. Two unknown terms. Which means one variable or one unknown term should be eliminated. So this is my task. It's like my mother used to call, like mother called me and giving me the directions to come to Nugegoda. Because after this one, when you come up to this stage, you already know how to solve two simultaneous equations with two unknown terms. So this is what I need to explain. This one you can do easily. What we have even, we just reminded it how to do this. Two simultaneous equations and two unknown terms. Okay, so I'll explain with the question. I'll start with this question. 2000, sorry, not 2000. Same set of questions. Question number 9. Same set of questions. Question number 9. We have a plus b plus c is equal to 6. You don't have to look at the dude, just look at the board. 2a minus b plus c equals 3. And 3a minus c equals 0. Now we have three simultaneous equations with three unknown terms. So I told you, what are we supposed to do? We need to bring this system down up to two equations consisting two unknown terms. But when you look at this, you can see already there is an equation which only consists with two unknown terms. Already there is an equation which only consists with two terms. Which means using these two, I need to try to eliminate B. I need to take out B from these two equations. So tell me how you can easily take out B from these two equations. I can add these two equations, no? So okay, now I'm adding these two equations. I'm adding the first one and the second one. I get A plus B plus C plus 2A minus B plus C is equal to 6 plus 3. So you can see plus B minus B cancel off. I get 3A plus 2C is equal to 9. 3A plus 2C is equal to 9. Okay, so this is my fourth equation. And now look at the two equations that I have boxed using the green color, that I have squared or boxed using the green color. We have two simultaneous equations consisting how many variables, how many unknown terms? Two simultaneous equations consisting how many unknown terms? Two unknown terms. So now tell me, can't you solve these? Can't you solve these two? Or that you can solve. You can solve this. So what I have done, I have brought down this system up to two equations consisting two unknown terms. How we can easily solve this? I consider this minus this, number 4 minus 3, which gives you 2A, 3A plus 2C minus 3A minus C equals 9 minus 0. I have 3A plus 2C minus 3A plus C is equal to 9. So this is something you know. You know how to do this. So C is equal to 3. I get C equals 3. So after finding one variable, it is a matter of substituting and finding the other variables. I'll go to the third equation. 3A minus C is equal to 0. 3A is equal to 3. I equals 1. A equals 1. I told you after finding one variable, it's a matter of simplification to find the other variables. After finding A and C, you can substitute it to any of these equations to find the remaining variable. So I'll substitute it to the first one. So when you substitute it to the first one, you have A is equal to 1 plus B plus C. C is equal to 3. I equals 6. B plus 4 equals 6. So I get B is equal to 2. After finding one variable, then it is a matter of simplification or substitution to find the other two variables. Okay. Okay. So again, I'll just explain this. Okay. Now look at this. Look at the board. What we do here is I have brought down this set of equations, three terms into two equations with two unknown terms. Clear? So for that purpose, one unknown term should be eliminated, but they have already eliminated one. They have already eliminated beta kattaka deela. They have already eliminated one. So I have used these two to take out B, and these are my two simultaneous equations with two variables. And then using your O-level maths knowledge, you can simplify this, and then you have to substitute to get the remaining one. Is it clear? So this is what we do. Even, let's say, even when we have four unknown terms consisting four equations consisting four unknown terms, we will be doing the same thing. Somehow you need to bring that system up to two simultaneous equations with two variables. Because if you can find those two, when you can bring it up to two, you can solve and find it, and then you can substitute to get the previous answers. Okay. In A levels, we are limited up to 4 variables, 4 unknown terms, 4 equations. But here, I have only included 3 equations and 3 unknown terms. But later, in some of the lessons, we might have simultaneous equations consisting 4 variables. For now, because it's just like the third day of the class, it's more than enough to do this 3 variables, 3 equations. Okay. Hands up if this method of elimination of one unknown term is clear. This is okay. Okay. Good. Then let's write in this way. Write in this way. To solve a system consisting of to solve a system consisting of to solve a system consisting of three simultaneous equations, three simultaneous equations, three simultaneous equations with 3 unknown terms, with 3 unknown terms. Okay, we need to reduce the system. We need to reduce the system. We need to reduce the system down to, so when you say reduce the system, you can't use up to normally. Not you can't use, we don't use up to because up means we are leveling it up. No. So reduce the system down to. Okay. Reduce this. We need to reduce the system down to 2 simultaneous equations. Reduce the system down to 2 simultaneous equations with 2 unknown terms. With 2 unknown terms. With 2 unknown terms. For this purpose, for this purpose, for this purpose, one unknown term, one unknown term should be eliminated. One unknown term should be eliminated. Okay. Okay, then just write this one. 3 equations, 3 unknown terms. The system has been reduced down to 2 equations, 2 unknown terms. 2 equations, 2 unknown terms. And then do the example, question number 9. So online students, if you have any doubts, do the same example, question number 9. If you can do it alone, better to do it alone. Get some help from the board. What if the third equation has a b in it? Okay, so let's do the next example in this way. So like there can be 3 equations consisting all 3 variables, unknown terms. So the next question, I'm going to take it. And someone has asked, can't we take that c is equal to 3a? Yeah, even you can do it that way. You can take c equals 3a, substitute it here and here. Then you have 2 equations with a and b. Then you can have 2 equations with a and b. Okay. Okay, so I'll explain this one even next one, question number 10. Okay, so this is what the one in the online class, someone in the online class has asked. So what if even the third equation consists of a b? So his question was like here, I have used this one because here we only have two variables. Okay, so his question was what happens if even b was here? Now look at this, look at the board. Okay, look at the board. Okay. I know you can do this alone. Huh? You need more time to do this. Oh, all done? Okay. So here, same thing. What do we have to do is you need to bring down this system of three equations up to two equations, two unknown terms. For that purpose, you need to eliminate one unknown term. So look at the equations clearly. Look at these equations clearly and you decide what is the unknown term that can be easily eliminated. You decide what is the unknown term that can be easily eliminated. What is the unknown term? A, B, O, C. Don't tell me Z, X, O, Y. Yeah? What is the easiest one we can eliminate here? It's the B, you know. The B. Why? Plus B minus B. So when you add these two, B eliminates and we have one equation consisting A and C. And now plus B minus C, when you add these two, then we are getting another equation consisting A and B. Even you can subtract this from this same term, subtracted B cancel off. So then first it's a decision to eliminate which unknown term. So we decide to eliminate B and then do the work accordingly. 1 plus 2, 1 plus 2, 2A plus B plus C plus 3A minus B plus C is equal to 15 plus 16. Okay, job 1 is done. B cancel off. I have 5A plus 2C is equal to 31. Okay, I'll name it as equation number 4. So this is my first simultaneous equation consisting two unknown terms. And then again add the first one and the third one. First one and the third one. 2A plus B plus C. 2A plus B plus C plus 4A minus B minus 2C equals 15 plus 12. Now B cancel off. I'm getting another one. 6A minus C equals 27. So I'm getting another simultaneous equation consisting only two variables, A and C. So I have decided to eliminate B. Now tell me, can or can't? Can you solve these two simultaneous equations? Can or can't? You can, no? Can do. Okay, so what did I do? I brought you to this. Okay, good. Same example. I brought this down to a position which you can easily simplify. Clear? So that's what you have to do. Okay, do this and continue. Finish the work of this question. First, you need to decide which unknown term to eliminate. Get complete this. So you said that three equations get reduced to two equations, but there are four equations in the total. No, it's not in that way. In this case, there are 5 equations. But what do I mean by 2 equations is these 2 equations. Huh? Not that altogether we have 5 equations. Okay, so here I'm referring that these 3 equations consist in 3 unknown terms has been reduced up to these 2 equations. The number is 4 and 5. That's because altogether we have 5. No? But what do I refer here? These 3 has been reduced up to these 2. In the previous one, only in the 2 equations. Okay, so here I refer to 2 equations is these 2 equations, which I have boxed. Okay, so then how to solve these 2? We have 2c and minus c. I'm going to multiply the 5th equation by 2. A 5th equation by 2 to get 12a minus 2c is equal to 27 into 2 is 54. So this is my 6th equation. Now it's not that we got 6 equations. Now I'm working with these 2. Just 6 is a number. Okay. Then we have minus 2c and plus 2c. And then add the 4th equation and the 6th one. Add the 4th equation and the 6th one to get 5a plus 2c plus 12a minus 2c is equal to 31 plus 54. Okay. A 2c cancel off. 17a equals 85. So a equals 85 over 17, which means a equals 5. A equals 5. So I told you when you get one answer, then it is a matter of substitution and simplification to get the remaining answers. So I'll get a equals 5. Then I'll use the 5th equation. I'll use the 5th equation to get 6a. I is 5 minus c is equal to 27. 30 minus c equals 27. 30 minus 27 is equal to c. We get c is equal to 3. But normally we don't keep an answer in this way. Yeah? We just don't keep the answer in this way. We have to write the, not a rule, but normally we write the unknown term first. Because 3 is not equal to 3 is not equal to c. C is what is equal to 3. Can you understand the difference? 3 is not equal to c. 3 is a number. Here c is what is equal to 3. You say a price of a bread is equal to 170. Not that 170 is equal to a price of a bread. No. Okay, so same thing. Is how much is a bread? 170. Don't know. You will eat those, you don't buy those, no? Okay, then after finding A and C, then let's substitute in the first equation, no? Okay, let's substitute in the first equation. Our first one, we have 2a, which is 2 into 5, plus b plus c, c is equal to 3. 15, 10 plus 3 plus b equals 15. So in the initial days, I'm doing every step of simplification. I'm doing every step of simplification for the better understanding of all. So I get b equals 2. Clear? Okay. Then do question number 12 and 17. To question number 12 and 17. So 12 is similar to question number 9 because there's already an equation with two variables. So you can think using question number 9. 12 and 17. After this, to question number 12 and 17. Okay, question number 12. We have three simultaneous equations, but here I can see that there's already one equation consisting two variables. Like here, even this one you can consider. But since the topmost one is that we only have C and 2A, I'm going to take out B using the second one and the third one. So add the second one and the third one. And when you add it, and again I'm mentioning, if you're like, you can even write in this way, when you add these two, you see plus B minus B cancel off, and you can write A plus 4C. So you can write it. You have the freedom in A levels. Keep in mind, you have the freedom to do any simplification by your mind. Even if you write a long step and then directly put the answer, still you get full marks. Okay, still you get full mark. In A levels, that is in that way. Because more amount of marks has been allocated to a method rather than simplification. In O levels, most amount of like the higher amount of marks has been allocated for the simplification process, the steps. But in A levels, higher amount is allocated for your method, the thinking, the logical thinking part, and simplification is really less. Let's say you are writing a long step, and directly when you write it equals to this answer directly, still you get the full amount of marks in A levels. That is in that way. Okay, so when you add these two, I'll just write it, but you can write it directly for A plus 4C minus B plus 3C is equal to minus 1 plus 15, which gives you a plus 4c equals 14. Okay, so these are the two equations that I'm working with. C plus 2a equals 0 and a plus 4c equals this. I'll multiply this by 2, the first one by 2. No, sorry, first one by 4, no? Because I need 4c. You can either multiply this by 2. Same. 4c plus 8a equals 0. This is my fifth equation. Now subtract 4 minus 5. You get a plus 4c minus 4c plus 8a equals 14 minus 0. A plus 4c I'm writing so everyone can easily understood is equal to 14. Minus 7a is equal to 14. So a equals 14 divided by minus 7, which gives you minus 2. A is equal to minus 2. So after getting one answer, you can easily find other two from the first one. A, C plus 2a. So C plus 2a equals 0. C minus 4 equals 0, giving me C equals 4. I have C equals 4. And then I can substitute it in the second one. Second equation, you don't have to write the sentences. Let's substitute the value of A and C in the second one. No, not needed. A is minus 2, B, C is 4, is equal to minus 1. Do I get B plus 2 equals minus 1? B equals minus 1 minus 2. So I get B equals minus 3. Okay, hands up in question number 12. We got the answers. A equals minus 2, B equals minus 3, and C equals 4. Hands up who got these answers. Good. Anyone in the online class, students, send me a message mentioning you got the answer. Question number 70. Now you tell me what is the variable that easily can be eliminated? What is the variable that easily can be eliminated? Z. No. Why do I say Z? Plus Z minus Z plus Z minus Z. I have the first equation and the second equation. 2x plus y plus z plus x plus 3y minus z equals 9 plus 11. 3x plus 4y is equal to 20. So this is one equation that I'm going to use. 3x plus 4y equals 20. And then can't talk. Second one and the third one. 3x plus 3y minus z plus 3x minus 2y plus z equals 11 plus 7. We have 4x plus y, which is equal to 18. Okay. So now I have two simultaneous equations with two variables. Now think how we're going to solve this. It's better to have 4y, no? Yeah. So I'll multiply this by 4 to get 4y. 4 into 4 is 16x plus 4y is equal to 36, 72. Okay, so this is your sixth equation. You have 4y. So why did I multiply by 4? To have 4y here and here. Sorry, then subtract 6 minus 4. Subtract 6 minus 4. I have 16x plus 4y minus 3x plus 4y is equal to 72 minus 20. Soon after you find one value, then easily you can find the other values. You get 52. 13x is equal to 52. So x equals 52 over 13. So x is equal to 4. Okay, so we have x equals 4. Let's substitute it here. Equation number 5. So why do I put the numbers here? Because in case if I do a mistake, it's easy to check my method and all the simplification. So that's why I have used the numbers. Let's say that I'm checking this. Okay, I need to check. If you haven't written the numbers, then you have to wonder like which two have you subtracted. So that's why I'm going with these numbers. 66 minus 4. Then it is clear I have subtracted this and this. And then I'm going to substitute it in the fifth one. Then it is easier to you if you want to check whether check a mistake, or you need to find where did you go wrong. So you have a clear notation of numbers and equations. Okay, so x equals 4 into 4 plus y equals 18. 16 plus y equals 18. Y equals 18 minus 16 means y is equal to 2. I get x equals 4, y equals 2. Let's substitute what is the easiest one, first one. I'll substitute this in the first one. 2x, 2 into 4 plus y is 2 plus z equals 9. Okay. 8 plus 2 plus z equals 9. Okay, so z equals 9 minus 10. I get the answer z equals minus 1. Okay, hands up who got x equals 4, y equals 2, z equals minus 1. Everyone got in. Wait, hands up, problem? Okay, good. And here I'm using this dash to distinguish z and 2y. If I'm just writing an English sentence, I don't use this one. If I'm, like, let's say I'm writing zoo, I'll just write in this way. If I'm writing an English word, I don't put this dash. But in maths, I use that to distinguish it between 2 and z. If you write 2z, then you think that this is like 22. To separate it with 2 only, I'm using a dash. Okay. Okay, then you can do the remaining at home. And if you have done this, you can get ready to go to all the remaining questions under question number 6 at home. Okay. Okay, so this is the month in, no, listen properly. Yeah, we are not done yet. I'll give you like more if you more. Need more time to, anyone who needs to cover, then all done. No? Right. Take your time, it's okay, because I think about every student in the class, not about the majority. I think consider about everyone. Don't write Zoom. Okay, no, focus. Like, don't keep watching your mobile phones because I'm still talking. Okay, look at me. So, two things. One thing is I need you to complete all the simultaneous equations in question number 6. And if you can do that today itself, it's better. We have already uploaded the answers in the group. Okay, the Telegram group, I think they have uploaded. I asked them to upload by 6 o'clock, but I think they have uploaded the answers of the simultaneous equations consist in 3 variables. So the answers are in the group. It's better if you can do it today itself when you go home, complete the work, and then check your answers with the marking scheme what they have uploaded. They means the paper panel students. And then newcomers, I need you to join to this Telegram group. It's 2028 Combined Maths EM. It's a public channel. So when you search it in Telegram, it pop-ups. So you can add to that channel. And in case if you won't be able to find the channel in Telegram, send a WhatsApp message to this number and get the link, because all the news and all the details regarding the classes will be uploaded in the Telegram group. Okay. So make sure you join in this Telegram group. Even online students, the same thing. Hope like you should be in the Telegram group because you have already joined the online class. So make sure you join this Telegram group. And today they will put a message in the Telegram group mentioning about a weekly question program. So what is the weekly question program? Every Monday and every Wednesday, we will be uploading a set of questions. Okay, every Monday and every Wednesday, we will be uploading a set of questions which we have done on that week in the class. So today I saw that they have uploaded few quadratic equations to factorize, and they have uploaded few simultaneous equations. So we first upload the questions on Monday, and then a marking will be uploaded on Tuesday. Listen. Don't get noticed. Like I have noticed this too much today. So if you get noticed, it will be noticed till the end of the class. Don't get noticed. Today, too much. Ready? Because I won't be giving high context through the 2 years. I'll be responding. Okay. So today they have uploaded a set of questions. Tomorrow they will upload the marking scheme for those questions. And again, Wednesday, we are uploading another set of questions. The marking will be uploaded on Thursday. Okay, I'll be checking those work on like next Monday, I'll be checking the work. So what you have to do, Monday when you see the questions, you don't have to do the questions one itself, but someday on the week, make sure you do the questions and compare your answers with the marking scheme. Don't just copy paste the marking scheme and come and show it to me. Okay, because you couldn't do that. You are just writing the marking itself and you're bringing it to me. Okay, to avoid that, I have included, like they have included some errors in the marking scheme. Okay, so we have included some errors in the marking scheme. If you copy paste the marking scheme and come in that way, you will easily be caught up for just copying the marking scheme. Okay, and do that questions, because those questions are normal questions to keep your practice and some creative, interested math questions. Those questions, there are some normal questions, set of creative questions. And you can ask any question when you come home. So there was a question, not come home, when you come to the class. You can ask any question from me. So there was a weekly question in this way. How can we solve this? How can you think in this way? You can do that. Even online students. So online students, I won't be able to like check whether you have done the work, but you need to have that discipline to do the questions properly and before next Monday. So before next Monday, you have to do that. And we'll be continuing this. And when we continue this, normally at the end of 2.5 years, there might be more than 600 plus weekly questions that you will be doing. Okay. And you don't have to maintain a separate book. Do the questions, do all the questions in the same book. Just put a topic, weekly question number 1, do the set of questions. Weekly question number 2, do the same set of questions. Why do I ask you to maintain the same book? Because we are doing some of the questions which we have done in the same week. So you don't have to maintain a separate book. If you maintain a separate book, you will do the homework, but you won't bring the book. Okay, so that's why you don't have to write it in a separate book. So even so we'll be doing this in a separate Telegram group. Don't come next week and tell me, say, I couldn't join the Telegram group. The link will be uploaded in the main group. So you are supposed to be in this group and then add to this new Telegram group, and you have to start they have already uploaded. Someday in the week, make sure that you do the questions properly. And especially new students, both online and physical, in the Telegram group, we have uploaded both the day 1 and day 2 recordings, which we have done basic mathematical concepts. But I advise you to at least watch the first 2.5 hours in the day 1, because I have comprehensively explained about the math stream and all the future careers and future paths that you can pursue if you do maths. And you need to, hands up who already registered in the website. Don't lie, I'm asking a student ID. Okay, so everyone, you have to register in this one. Online students as 2028 English medium online. You as 2028 COKM, I guess, so physical English medium. Because then you get a student ID. We will be having our first exam at the end of April after completing this, and 2 more lessons. The first exam, to write that exam, you need to have the student ID. Okay, so you have to get registered in this one and attend one. And the other one is attend classes properly. I know there is a fuel crisis. There might be problems. There might be transport issues and all. But if you won't be able to make the class physically, if you won't be able to attend the class physically, have the discipline at least to join the live online session, which is parallelly live stream in same time. So if you won't be, because of a transport issue, because there are a global crisis going on, even though I said that good news are coming, that Trump has said that he is discussing with Iran. He have already had discussions with Iran. The Iran has rejected that. They have said, no, we didn't have any discussions with Trump. Okay, so good news, I have to take it back. So we don't know what will happen. Not sure about all these. If you won't be able to attend the class physically, join the online class. And still, if you won't be able to join the online class, the recording will be uploaded soon after this class is finished. So make sure you watch the recording and then come to the class next week. So then you can smoothly continue the class without any lag or any problem. Okay, we're done for today. You can go home safe.